Okay, hello, welcome to Practice Problems for Homework 13A. As always, before we jump in, we want to make sure we're prepared to start solving problems. So we want to make sure we've watched the associated lecture. That would be the handout 13A lecture. And you want to make sure that you've solved the numerical problems in the lecture from scratch. That's particularly important in this case. There are several problems that I do go carefully through from scratch in the lecture that are virtually identical to what you will see in the homework. And so I'm not going to repeat solving that type of problem here. So you'll need to find those in the lecture. And then, as always, we want to have our concepts, definitions, formulas, PDF at hand. I've got that over here ready for us to use it if needed. Okay, so let's jump in. So the first thing we've got here is some information for questions 1 through 3, and I've got some historical annual returns for the XX ETF. So just annual return for 2005 all the way up to 2019. So question number 1 is, what is the average return? Compute this to 3 decimal places. Do not represent your answer as a percent. Okay, in this case, you're going to see something like this on the homework. There's nothing for it but to just carefully type these numbers into something. I've done it myself. It took less than 4 minutes for me to type these in. I typed them into Excel from scratch. And then once you've got them into something like Excel or some kind of fancy calculator, then it's very easy to do something like this. In Excel, we could use the average function and go put that there. And so that gives us 9.4%. So I think that's good. And the second one, again, just a little bit of reminder about statistics. How do we actually go about analyzing our historical return data? The two things we're going to need typically are the expected value and the standard deviation. So that's question number 2. What's the standard deviation of the returns? And we say here, hint, use the sample standard deviation formula. You can Google that if you're not using Excel. If you're using Excel, it's literally just the STDEV formula without the P on the end. P stands for population. So to get the sample, we won't use that. So I'll just say down here that we want the standard deviation of all of our returns. Okay, and so that's about 19.1%. So that's it for that. Now let's go through this type of question, and using a normal probability density function graph like this is going to be important on the homework and on the next exam. So let's do a couple questions using this particular one here. So we've analyzed 30 years of historical annual returns of a stock, and you found the average return to be 5% and the standard deviation to be 15%. You'll estimate future returns for better or worse as normally distributed based on your historical analysis. And as we learned in lecture 13A, that may well be for worse, but we're going to go ahead and go for it anyway. So now let's go to question 3. What is the probability that in any given year the stock return will be 35% or better? 3 decimal places, do not answer as a percent. Okay, so in a case like this, we do need to be a little bit sneaky, and we need to notice that 35% is equal to what? It's equal to 5% plus 15% plus 15%, and that's equal to our expected value. Remember, we're saying that these returns are normally distributed, so we can use mu for the normal distribution plus 2 standard deviations. Okay, so once we have noted that, and that's going to be an important first step, then we can go on to completely solve the problem here. And so what I want, so here I am at mu, no standard deviations away from mu. Again, the x-axis is measured in standard deviations, and the percentages here are probabilities. Okay, so I need to go 2 standard deviations above the expected value. Here's 1, here's 2. So the probability that I need is going to be the area under the curve up here. So that's simply going to be 2.1% plus 0.2%, okay? And in most circles, that's 2.3%, okay? So the probability of return being 35% or more is 2.3%. Okay, so this is very important that you understand this, so please take some time with that. Okay, let's do another one. What's the probability that in any given future year the stock return will be minus 10% or worse? Okay, so once again, we need to do something like this. We need to say that minus 10% is equal to our expected value return minus 1 standard deviation. Okay, so that again is equal to our expected value return minus 1 standard deviation. And now that we understand that, we can just go up to the graph. It says or worse, so that means I want the left tail stuff up here. So I want this whole portion of the left tail, because here's my mu, no standard deviations away from the mean, and here's 1 standard deviation of the mean. So I want the area under the curve from minus infinity, and which is close enough to minus 100%, all the way up to here at 1 standard deviation away. So I just want 0.2 plus 2.1 plus 13.6. So that's going to be 0.2% plus 2.1% plus, I think I said 13.6%, yep, 13.6%. And if we work that out, I think I can even do that in my head. Always a little bit doubtful, but we can give it a try here. That's looking to me like 15.9%. Okay, so how do we say that in words? We have a 15.9% probability that in any given year the stock return will be 10% or worse. Okay, and now finally, using the information given for problems 3 and 4 above, could you estimate the value at risk of this stock's annual returns? Well, I have no idea. I need to remind myself that value at risk rings a bell. I didn't memorize the definition. I should have, but I admit I didn't. So I'm going to go to concepts, definitions, formulas, and I'm going to just search for VAR, or I could search for value at risk. That's not so helpful. That's not so helpful. But here we go. And here's our definition. Value at risk is X, where there's a 5% probability that our return will be X or less. Okay. So that means 5% probability. So what I have to do here is look on the graph, and it's or worse. So I want to be looking in this left tail. And I'm going to be able to get the value at risk if I can add up some of these to get 5%. And I cannot, okay? I can add this one from 4 standard deviations away from the mean to 3, and 3 to 2, add those 2 together and get 2.3%, but now I jump up here to 13.6%. There's no way with the data given to me on this graph that I could compute the value at risk, okay? So we're going to say no, VAR. And I'll just write this down again. VAR is X such that probability that return is X or less is 5%, 5% not shown above. Okay, and we just can't do it with the information that we have. We know how we could do it, which I can't ask you on a test, but good to know is our norm inverse function here, and our probability is 5%, and our mean is 5%, and our standard deviation is 15%. Okay, and so our x would be about minus 20%. So once in every 20 years with this stock, we'd expect a return of about minus 20% or worse. Could be a lot worse. Okay, and I think that's it for this edition of practice problems, in particular practice problems for homework 13A. So I will stop it here and look forward to catching up with you again sometime soon.